Thanks, everyone. Thanks for coming out on this beautiful afternoon. Thankfully, I'm not speaking, so you don't have to endure my terrible, corny jokes. But we do have someone who is giving a talk on applying the CIS benchmark using Ansible and Packer. So Richard Bullington-McGuire is a principal architect at Modus Create. I'm not going to steal his thunder. Richard, why don't you come up and so we're looking forward to this talk. Please make this interactive. The more, well, actually, I shouldn't speak for Richard, but usually the more interactive our talks are, the more valuable they are. So, yeah, sorry.
Great. All right, I'll restate mine.
Yes. No, I'm just kidding. Yeah, no, seriously though, we're really looking forward to having you. Yes, thanks, Richard.
Okay, is that good? Can folks hear me okay? All right. Well, thank you very much for giving me the opportunity to speak again. I wanted to share some of the experiences I've had related to compliance with the group, and specifically share some of the techniques that I've been able to use in past engagements to help organizations get towards a compliance goal. This is often a very ambiguous process. Okay, like what's going on with compliance? There's compliance standards out there, that folks might have heard of that might apply to full information systems or to the configuration of an individual system. Does anyone can anyone name a compliance standard that might apply to the configuration of a Linux server, for instance? PCI compliance, right. So PCI compliance has to do with cardholder information for credit cards. And it has very specific recommendations about what has to be encrypted and where it has to be encrypted and how the systems have to be configured for logging and access and so on. So if you deal with cardholder information and payment systems, that is the standard for you to deal with. There are other standards for security that are way, way looser though. Okay, people have probably heard a lot about GDPR recently, okay, which has some very broad guidelines. And I'm not going to give a GDPR talk here. There are other standards like FERPA, which has to deal with the privacy of educational records, that are similarly very broad. So what do you do if you need to have strong security controls, but you don't necessarily fit into a bucket like PCI? So this is where having something like the CIS benchmark comes in handy. Folks are probably familiar with the SANS Institute. Okay, for a long time they maintained a top 20 threat list. The custody of that list has gone to this Center for Internet Security organization. So it's a nonprofit. They maintain that checklist. They run an incident type center, and they also have a consensus process to derive security controls for a huge variety of systems. So I encountered this last year because a company I was doing work with wanted to make their systems that were moving to the cloud comply with the CIS benchmark. Okay? So and I thought, hey, this is great because I've done a bunch of compliance work before. I worked on a system called Forge.mil, which was met with very lukewarm developer acceptance, but had a lot of enthusiasm with the Defense Department. It was like a SourceForge Enterprise / TeamForge for DoD. And there I learned about really serious compliance processes. DISA, Defense Intelligence Systems Agency, has security technical implementation guides. So that's a huge checklist of rules that you have to follow if you want to put a system on a military or government network. It has a lot to do with encryption, has a lot to do with auditing, but it's a major deal. And if you work in those systems, there's often a whole department Like you might have a quarter of your team dedicated to compliance, okay? You know, you might have, like this team, there were 4 or 5 developers, and there were like 8 compliance people who had to check boxes and make sure that it was all good with the security officer. I've also dealt with PCI compliance with multiple commercial clients, done some audits of systems to make sure that the right kind of encryption was being used and in the right places. You know, and then there was this work that I did last year with a client dealing with the CIS benchmark. And with those, you have to deal with FERPA, which is Federal Educational Privacy Rights set of compliance things. So with this, very loose. Basically says you have to keep students' information secret. Okay, don't leak it. If you're found to have leaked someone's proprietary information, someone can complain against you. And if you're found to be in violation, we could cut off your federal funding. Your organization could be ineligible for grants and loans. So if you're a university or a school and you run your information systems, or you are a company that sells to universities, you do not want to be in violation of this. So you have to use the same kind of techniques that you would use for securing these financial systems to do that. And one way to do that is by locking down your baseline configurations so that they have very strong controls on who can get in, what's audited, the systems that are not required for operation or shut down. A lot of these things are common sense, but it's great to have a standard. So the CIS benchmark is one of these ways to do this. Now, the Center for Internet Security gives away the CIS benchmark for free. This is part of their public benefit. So they give away PDFs, okay? So this is hundreds of pages of information on how to secure your system if you're using CentOS 7. I downloaded a few of these, so you can see that there's, you know, like Linux benchmark, web service foundations for AWS, Ubuntu, you know, like I sampled these. I sampled a few of these, you know, while I was doing this. But this specific one is one that I had direct experience working with. So I wanted to figure out if it was possible to share my experience in applying this with the wider audience in a way that was redistributable. And succeeded in part with this. Didn't meet all the goals I wanted to, but succeeded in part. And if, you know, the specific controls that are in here go right down to the level about making sure that permissions are set on certain files, that certain partitions are created in different ways. It's extremely detailed. Okay, there's a lot of items here. One of the things that I found when I was looking for this is that there were related standards, like this U.S. Government Commercial Cloud Services standard, the C2S standard. Now, I'd already applied the CIS benchmark, you know, commercially with a client. And in that engagement, we'd used Nessus to do security scans, and it spit out the CIS benchmark checklist, which was great. You know, and I wanted to find a set of tooling that would do that. And I found some very interesting things about, like, what can you do, you know, for free if you want to get started on something like this. There's some barriers to entry. Okay? And there are lots of different standards, and some of these are easier to scan for than others. Okay? Why don't people do this all the time? Yeah. Doing it the traditional way, like people did it, you know, for the defense systems that I was involved with, really slow, really expensive. In that, you might have a sysadmin group with the standards document, and they would manually build a checklist for every system and manually do the remediations and have someone else check it and make sure that you had hundreds of items all locked down. This is hideously expensive. Now, That's not going to work in a world where you have dozens or hundreds of servers in the cloud. Maybe some of them are summoned up and then go away in the span of an hour. The automated tools available in this area leave a little bit to be desired, though. Okay? Even the best tools are not going to be able to scan for everything. There are compliance items in these checklists that there's not a script you can run on a machine necessarily that's going to ensure it's in full compliance. Tools are also kind of expensive. Okay? Now, you might have to pay thousands and thousands of dollars a year for licenses to some of the tools or the techniques or some of the source files that are required if you really wanted to gain full compliance. But we can use infrastructure as code techniques to make some of this less painful. Okay. And how does it work? All right. Does anyone work in, yes? Sure. So I've got some experience dealing with Nessus, for example. Okay. And no, at least with the level of code that I had access to with the customer, now you could install an agent on the machine. You could have it register with its host name with the central service. But you know, I don't know what the exact path is there to initiate a scan, make sure the scan is complete, and then have the scan, you know, like recorded somewhere. Okay, like that's R&D to me. Okay, and there's a free set of tools out there which I've always wanted to use, and I got a chance to use here, called OpenSCAP. Okay, but I found that there was a key barrier to doing a full scan with OpenSCAP with the CIS profile, in that the files that are required, you have to be a member of the CIS organization, which can be very expensive. It's usually in the thousands of dollars per year, and it's done on a sliding scale depending on the revenue of your company, you know, other factors like that. So if you're going to do, does anybody here work in an organization that has a security officer, a formal security process? Okay, and you know, some folks do, and that, and the folks who are the security officers who have a formal security process, they live for the compliance stuff usually. They want to make sure that you have adequate defenses in place, and adhering to standards like this is a good way to do that. So how do you start out doing this? Now, what if someone says, we need to have better security? Well, we could apply some of the publicly available standards for doing this, like the CIS benchmark. So the thing to start is to start with the standards document, okay? And you need to build a checklist. And with the checklist, you could do something as simple as copy the table of contents, you know, and edit it a bit and get it into a spreadsheet of some kind. In previous compliance engagements, there's been a spreadsheet, a compliance matrix. So you have a section. Your security officer may help you understand which sections are applicable, because not every control is going to work for every system. And then you need to have some way of tracking the status of the section or the specific mitigations. And I suggest using an issue tracker to do that, and then using the issue tracker to prioritize things. So one of the interesting things I encountered is that the CIS benchmarks themselves are licensed under an attribution share-alike non-commercial license. So I can't share the spreadsheet, like the actual derivative, with you. So I've got a little excerpt here, you know, under fair use, but you know, if there's any question about commercial in it, you can't do it. So the CIS organization, like many nonprofits that work in technology, they have a bit of a gate. Okay, so are there any IEEE members or ACM members out there in the audience? Okay, like, you know how to get access to the digital library, you've got to fork over extra Well, they gatekeep around some of the most valuable products with their organization too, which is their prerogative, but it was a little frustrating to me not to be able to get the all the tools that I wanted. I'm like, hey, there's this great security nonprofit, but without ponying up for membership, I couldn't get all the stuff. So if you build a compliance matrix like this, and then you have a way of doing a scan, you might be able to fill in whole sections of this matrix in short order. Okay? If not, then you have to do it the old-fashioned way, and go through all however many hundred items there are. So in this particular compliance matrix, there'd be 254 items to check individually, which is really painful. So you want to have some way of automating that. Now, this talks a little bit about the barriers that I mentioned. It's a lot of money to become a member, which I didn't have budget for this talk. There are some really great free resources that are available from CIS, like the benchmark files themselves. There's also a CIS Cat Lite tool, which is a desktop scanner that will let you scan versus Windows or Ubuntu, but it also has limited features and some use restrictions. So there's a CIS Cat Pro is available that will scan the full thing, but it's a members-only tool. Furthermore, the tools that OpenSCAP would use, the XCDDF and OVO files, are members only. So you could use the Open Scanning Framework if you're a member. So if you really want to do this, I would encourage you to investigate, being a member of the organization. It may be worth it for you. There's also commercial tools like Nessus. They have a license. They've paid these folks for a license to the tools and the framework, so they can then submit that their software will do a CIS compliance scan. Okay, so this is how I was able to do it with the customer. So given the barriers there with the automated or with the manual testing, it's going to be a long, long road to try to test that. So you need to find some way of making it sane. If you use an image bakery pattern where you take a baseline operating system image, apply some changes to it, and then you're able to scan that and use that, that's fairly sane. So the path that's laid out in this presentation and in the linked repository uses Packer to bake EC2 AMIs, uses Ansible to provision the image with CIS baseline playbook, and uses OpenSCAP, which is a set of security tools derived from government standards, sponsored by NIST, to have like a set of open security scanning tools. And I'd always wanted to use this set of tools to do something real, so I got the chance to do it with this talk. And I just used the things that were really familiar to me that I knew would give lift to someone who is trying to do this. So its infrastructure is code. It's all on GitHub. I used Vagrant to do local development environment testing to make it faster than baking an image. Because if you make one change and then you have to bake an EC2 image to see whether the change worked, it can take a really long time. It's faster to have a local environment where you can keep testing the changes in your provisioning system. And then I use Jenkins to orchestrate the whole thing and have it tie into to GitHub, in part because I like the GitHub pull request system where you can see whether that worked or not. Okay. So I'm going to show a little bit of the okay. So I've got the code here in a publicly available repo. The bit.ly URL goes straight to this tag. And this has the basic instructions on making this work. Now this has a Jenkins file that will invoke Packer through a Docker file. It's nice and easy to, because this tool is Dockerized, you can just tell it to invoke things with the Docker invocation rather than having it install the software from scratch, from a repo. It becomes, a relatively concise Docker invocation to get that going. So, like from here, let's see. How does it all fit together? Okay, for local development for something like this, I would recommend having an environment where you can run your provisioning scripts, which might be Ansible, they might be Chef, they might be SaltStack, they might be just bash scripts or whatever. I use the Ansible here because I know of a playbook that has the CIS lockdown routines already in it. So for local development, the same way to do it is to try to apply this playbook to a baseline image, so CentOS, for instance, and just make sure that you get it running like that. And then you can have Packer invoke the same scripts that you use from Vagrant to provision the image over on EC2. If you do that, you can also have a CI environment where Jenkins will use Docker to run Packer and then spawn the EC2 instance and run the playbook on that EC2 instance. So the proof of concept here. Code's in GitHub. We can use GitHub pull requests in Jenkins to make sure that that things continue to build even while we're making changes. We can run an OpenSCAP scan after we do our provisioning to, to start with to see where things are. And because I couldn't get the CIS benchmark files for OpenSCAP, I used C2S, which is derived from it. And it turns out that there are mappings in the C2S files for OpenSCAP that have some of the references from the CIS documents in them. So we can at least cross-reference that and show that we are hitting one of the, and remediating one of the issues that is in the CIS benchmark. So, I couldn't do the CIS Cat Pro or Lite or Nessus. It was too much to try to put together. But this path, I was able to put together. Okay. So I'm going to show a few things here. Now we have Jenkins running a Jenkins file. And I've got several branches that are in play here. The baseline demo one here does not yet have the Ansible fixes applied to it, so it didn't run the Ansible playbook that did the baseline bit. And I went a little farther, and I also remediated one of the issues that the Ansible playbooks, themselves did not fix. Okay. So at the end, you'll get an evaluation report. Okay, so I'm going to show the report a little bit, and then I'm going to show a few things about how this is all hooked together underneath. Are folks okay looking at code? Is this workable right now? Okay. All right. So this report is a compliance report versus the CIS or the C2S benchmark. Okay. And note that it has all of these oops, it has all of these warnings here about where it came from, some disclaimers. The C2S benchmark is not the CIS benchmark, and you can't use the C2S benchmark formally to show that you're complying with the CIS benchmark. But for our purposes today, it's good enough because it covers many of the same issues. So I ran this first versus the baseline CentOS VM that I had access to through the EC2 subscription. And it came out with a 56 passed, 17 failed, and 2 error states with a score of 80.23. Okay. So this is the baseline. So with this particular scan, we did okay. Okay. We have more passing than failing, which is fabulous. So let's look a little bit how that goes together. Okay. So one way of dealing with this is to do that local development. Okay, so with Vagrant, it's pretty easy to grab a base box and then run a provisioner. Okay, so here I used a CentOS 7 box that already had the VirtualBox extensions in it, because if you don't have that, you need to install other plugins that will install the VirtualBox extensions. It's kind of a pain. So we could have used CentOS/7 here, but this one was just a little easier to get going. I used the sync folder with /app because that's also the convention that I used when dealing with the Docker Packer. So instead of mounting it on /vagrant, I mounted things on /app. So the directory, the source directory, is available in the VM under /app when we run Vagrant. And then it installs Ansible using a simple shell script, which just pulls it from the EPEL repo, or installs the EPEL repo, and then installs the Ansible RPMs. And then we run the Ansible playbook in kind of local mode here. So the script that installs Ansible is pretty simple. One of the things that I have it doing is looking at a requirements file, which lets me pull in Ansible roles from Ansible Galaxy. This way I did not have to copy this role into my repo, which might be a valid choice depending on whether you want to kind of checkpoint the exact versions you're using. Maybe you do want to clone this role out of GitHub and put it into your own source control system and update it by hand. Maybe you want to extend it there. Maybe you don't. And then when Ansible playbook runs, it will go through all of the rules that are present in the playbook. And this one is from MindPoint Group, which is it's a playbook that I'd used before. Okay. So the OpenSCAP tools are interesting in that they can actually generate shell script remediation tools or Puppet fixes or Ansible fixes. But the playbook that it generates is pretty rudimentary. Like this one is something that people have been working on over the course of several years. It's very actively maintained. It has a pretty active set of contributors. And there's activity in it that's pretty interesting as far as what people are doing with it. You can see the Ansible playbook running here, in my Vagrant app. So this is making sure that everything is locked down, that is covered in the CIS baseline within reason. Okay, this playbook does not completely lock down a system so that it's going to be fully compatible. But that's one of the rough points about dealing with compliance. Automated tools are almost never going to get you 100% of the way there. There's always going to be something that you're going to need to do. So it's a process. One of the interesting things about this playbook is that there's been work this year to integrate this particular set of tests with, or this particular playbook, this set of remediations with CIS Cat Pro. So if you remember, you could get this tool and run and use it to validate that this set of remediations work. I found that to be very interesting, and if I had more time to work on this now, I probably want to dig in much deeper on that. The contributor says that auditing the rule had high value because it showed gaps in it. So you really do want to go back to the source if you can, some of this stuff. So it doesn't take very long to do this particular playbook. And then it doesn't take very long either to do the scan. So I'm actually doing an OpenSCAP scan on my local box here during this vagrant provision run. So I'm doing this path. Okay. So this is going to finish up here in a minute. So you can also run invoke Packer from the local workstation too. So this little shell script I have is a wrapper to run Packer, first with a validate command and then with a build command. So with Packer, you have a configuration for a machine which might inject environment variables. It'll have one or more builders that will let you actually instantiate a machine somewhere. So it might be a Vagrant box builder, it might be a VMware builder. This one is set up for Amazon with Amazon EC2 with an EBS-backed volume. So the provisioning in here is relatively simple. It's basically run some shell scripts and upload some files. I run install Ansible the same way I would on the Vagrant file, and I run the Ansible playbook. There is one interesting thing here where I'm using, like, Packer and Vagrant both have support for running Ansible locally on the target machine. And I tried to do that this time, and I was reminded of why it was a bad idea in this specific case. So the CIS remediation playbook makes sure that the temp directory is running on tempfs, okay, which wasn't originally in this particular image. So it actually kills the existing temp directory as part of its run. But if you use the Ansible local provisioner, in Vagrant or in Packer, well, it's going to upload stuff to temp. So it's going to die halfway through. One of the things that this does also is it downloads the build products, which in this case are the output of the scan. So the scanning in this is relatively simple too. So we create a build directory after we install the scanner tools, and then we run an eval command with the OpenSCAP tools with the C2S profile, and we tell it to use the CentOS XCCDF files and output a results file. And then we generate a report from that. So the tools themselves will generate an XML file that you can use other tools to build or to work on. And you can use that XML file to generate an HTML file. It's also possible to generate a guide with this where, with the OpenSCAP tools, that'll actually give you, with the particular policy that you have, it will give you a complete guide to locking down every issue, which you can also use in making sure that if you're doing a checklist-driven path to do this, that you've got all of these. So let's see. And one of the things that I found really interesting about this was that these have some references. Yeah, here we go. So, like this particular one, add no dev option to removable media options, okay, has a reference to 1.1.18 of the CIS benchmarks file, okay? So because this C2S profile is derived from the CIS benchmark profile in part, it has some of the security identifiers that are in it. Okay, so I'm going to go ahead and I guess I won't run that from my local instance right now. I'm going to show a little bit about running this from Jenkins. If that's good. Yep. They do offer their own set of EC2 AMIs. I think it's worth exploring. Okay, like if the vendor has a set of pre-baked, stuff that they say is good as a baseline, then it's worth considering whether you want to start with that and then layer your own stuff in, or whether you want to start from first principles and make sure that you can verify that it's done yourself. So I thought that was cool. But if you don't scan the stuff, how are you going to verify to your security officer that it fits the profile completely? Yeah, and you need to be able to scan, like, if like you do a package installation on that and it breaks, okay, you need to be able to run the scan. So even if you're starting out with a pre-validated image, like the process of being able to scan as part of your own image baking process, even if you start that with a baseline, but then let's say you install 10 different operating system packages, including 3 of your own custom ones. Like, is it going to break something? So, now, when I was going through this, I wanted to make sure that that I could show fixing a specific item. Okay, what I picked was a root direct root logins not allowed. Okay, so when I applied the CIS baseline at first, like, well, how can I show some value here about doing this process? Okay, and this direct root logins not allowed is linked in the CIS benchmark. It's in section 5.5. So if we take a look at CIS benchmark, and we can look back at the original reference for 5.5 and see ensure root login is restricted to system console. So it has an audit recommendation. Make sure etc secure TTY has a list of valid terminals. And the original problem in this one was an error. So the first scan I did was not able to properly detect whether this was really remediated or not. Okay. So I had to change both. I had to add a rule. I added an extra Ansible playbook that locked this down hard. And I changed the way that the scan was done so that it sudoed the scan so that it could actually read this file. I think it was originally an error in part because it couldn't actually read etc secure TTY because it's a root-owned file. Now, the CIS controls itself here, they have a very vague remediation, okay? This does not tell you exactly what's allowed and what's not allowed, okay? So you have to use your judgment as someone working on compliance whether your remediation really fits, and then you have to be able to justify it to the security officer if they dig deeper, okay? So the tool is capable of generating a set of fixes in order to try to fix this. Okay. Let's see. It's secure TY. That's the easy way. So it suggests here doing echo greater than etc secure TTY, which ought to work okay as long as this is definitely running as root. But not all the, like a lot of the fixes in the generated Ansible playbook here, like were not fully cooked. I tried to run this like on top of the playbook that I already had, and it errored out partway through. I'm like, oh boy, I'm gonna have to go and try to fix this. So if I had, you know, dozens of hours to try to go through this, then maybe I would have done that. Instead, I did a little research and looked at what could be done to really fix it, lock it down hard. So I created a little playbook called Extra CIS Remediation and put in one task to do this. I found a lovely Stack Overflow post that talked about how to ensure that a file existed, and I adapted that to force the content of that file to be empty and to make sure that it is owned by the correct group and owner and has the correct permission bits, which is a more comprehensive fix than the one that was suggested about just doing an echo greater than, okay? They would probably result in the same thing at the end, but this one hits it, be really sure. And I also added the tags that were in the suggested playbook and in the original CIS baseline playbook from Mindpoint Group, just so this would be compatible with the most number of tools. And with that in place, we can actually show that this branch and these artifacts oh, it's not that artifact. Fix root login. This is when the demo gods are not smiling on me. I had this all queued up so nicely. Oh, it's the pull request, that's right. So here we go. The output of this that has the fixed report. Okay, now we have 65 passed instead of our baseline of 64 passed. Hooray. Okay, we've remedied one issue, okay? So, you know, and it took a couple hours to tear through one of these issues, which is why it's important to work with your security officer to prioritize what fixes have to come. Yeah. it might be unusable. And in practice, what has to happen is you have to work with the security team wherever you are to ensure that any exceptions to the process are documented and known. Okay? Some security processes have a very formal way of doing this. Like in the defense and government systems, there's a process called POAM, okay? Now, which is plan of action and mediation, okay? And there's an extremely set of formal processes that say that if there are exceptions to this, then you have to fix them in X amount of time, or they have to be signed off at the highest level by the chief high muckety muck of whatever, okay? And that's going to be the case in most practical systems. In most practical systems, even if you're required to be compliant, you're going to have systems that are not completely compliant when they start. You're going to have to live with some issues, okay? Sometimes you can't, and they'll just shut you down. You're like, it's too big of a risk. But in my experience, it's usually the case that they'll get things locked down enough that they're comfortable going out, and then they will prioritize those fixes over time. Okay, that's a good one. So part of it is you might exclude some things from your scan by policy. Like this particular playbook has a bunch of Boolean variables in it that let you say like certain features are not going to be scanned for, or this control is not going to be part of our profile. Okay, you might also write a post processor. So this particular scan tool, the OpenSCAP, gives you an XML file that has all of the things in it that it finds. And you could write a secondary process that looks at that and whitelists or blacklists certain areas, okay, and make sure that your CI tool will fail if something that is in the set of controls that you have to have is broken, or these 10 controls, we know these are going to fail, and it's okay, we're going to pass the build anyway. So if you were going to reproduce something like this from first principles, getting the scan working is the first thing you probably ought to try on your baseline. And you should try to get the AMI to build or get your image to build one way or another. Make sure you can run the same set of scripts on a local environment that you can run in a cloud environment. The last thing might be to get Jenkins running Packer, run it on every commit or pull request, integrate it with GitHub. And there are some things about this that I learned, like the thing I mentioned with the Packer and Vagrant provisioners. Like you can't rely on that temp directory. Now, using an issue tracking system to prioritize remediations in practice is definitely the way to go. So if you were really going to do this, you would definitely want to use Trello or Jira or something like that to prioritize the various things here. And that's something that I did for real with the customer last year. They had a multiple 100-line spreadsheet, and we tracked every issue that was outstanding that their security officer said had to be tracked, and that work stream got prioritized with the rest of the development work stream. Mm-hmm. No, so in that case, the initial automation that got there was like, okay, we have our baseline operating system image. It was CentOS in that case too. They ran an SS scan on it, and I think that ended up generating the spreadsheet in that case, the original. Okay, and that showed that before it was something like 30% remediated before any changes happened, and then after the raw role was applied, it was something like 85% remediated. So that was a big win. So you have to generate that spreadsheet somehow. So your tool may spit it out for you, which is great if it will. You might be able to generate it from, like an XML file directly. Like if you take the guide and and munge it. And it's enough sometimes. If you can get automation in place that'll get you to 80+% of compliance, to go through and do the rest manually. Okay? Even if you can't have an output of your CI process that will scan every time, you can remediate a batch of 5 or 6 issues and then have someone run a scan on one of the systems anyway, and then feed that back into the system. So, this is a messy process. There's always going to be ambiguity. There's always going to be some things that you have to do manually. So it's. Yeah, that's. What is that, right? And but there are tools out here like this, like the OpenSCAP suite, that are very mature and freely available. And if people just would make their content available more widely and have it work with this process would be so much easier. That fed into the engagement that I worked on last year. That was opaque to me. It was like, the auditors are coming. We need to be prepared. So we'll do this. And this will satisfy them for now. So the security officer and the whole security team dealt with making sure that whatever they really wanted was taken care of. So it was taken care of sufficiently that it wasn't a problem. And it was removed from me. So I had to be the hands on that part. I didn't get to be the brain on that part. I haven't been the security officer. And my colleague over here, Andy, might have a little more insight into some of the security officer stuff than I do. I just have to get it done. So, I really wish I could have used the CIS benchmark OpenSCAP files to do the scan, because then it would have been like, hey, this is perfect. But my company's not yet a member, and for me to personally be a member, the personal membership is about $3,000 a year. But it looks like it would be a good path to go. Any other questions? Yeah. That's an excellent question. Okay. So the way I've worked it is to do all the remediations with a baseline operating system image and then install your application on top of it. Okay. And then there's a final scan that might happen to make sure that you have a backslide in compliance. Okay. So with the customer that I work with, we used the baseline image, we did the baseline, there was a scan with a non-remediated bit, then we remediated it, and we used a very simple application to one of a portfolio of dozens, in this case, of applications that had to be built on top of the baseline in order to validate that it was okay. To really be thorough about it, you would want to do a scan with every application deployment. Okay, or at least have that as an option in your pipeline. And unless it's fully automated like this, it's just not going to happen. So that level of rigor would be good to get to. Well, this particular tooling with the profile I used, which might be half of the total items in the CIS baseline, was pretty quick to do. So it would be something that you could run with every deployment. At least on one node, representative, or when you're packaging the software, you could do a canary deployment somewhere and run a scan versus it without any big problems. It was 3 to 10 minute type scan for this particular set of policies. Yep. User permissions review, like a Unix user permission sort of thing, or are you talking about how to get a set of users that might be in some directory, limited access to machine? So you might need to build your own set of compliance rules to do that. And I'd suggest looking at the OpenSCAP toolkit, because you could very easily build a set of custom rules that would have a scan that would show compliance or not, and then implement that as part of this. Like, this would be a good way to do it with open source tools that you can bend to your will. The output is nice. Now, I don't know how hard it is to build some of those from scratch. So I might have said easy, but really I have no idea because I haven't done it myself. Okay? But it seems like it would be a good path to take. All right, thank you very much.